So in this video, we are going to look at another example of finding the area between two curves. But this one, they're not going to tell me the specific x value. So in the previous video, we did one and they told me x1 and x2, but in this one, they're not going to tell me, so I will have to find it. So we're going to look at how to do that. So this question says, find the area of the region bounded by the curves y equals negative x squared plus 6x minus 5 and y equals 2x minus 5. So when we do these problems, when we're finding the area between two curves, we find the integral, and I'm going to call it x1 and x2. These are where the two curves intersect. And then we do f of x minus g of x dx. Okay. And f of x is always the curve that is above the other curve in this region when we're looking at these x values. So it's higher on the y-axis is what our f of x is, and g of x is lower on the y-axis. The one key thing is if you have it backwards, you will get a negative number, and you can't have a negative number for area. So that means you should have switched it, or you made a mistake when solving. But you can always check the definite integral by your calculator. And then if you do get a negative, that means you need to switch the order. Okay, so we need to figure out which curve is on top, and then we also need to figure out the bounds that we need. So you can find the bounds either graphically by using your calculator or algebraically by setting the two curves equal to each other. And it doesn't matter which way you do, it's whatever you find easier. I'm going to set these first equal to each other to find the bounds. And one of the reasons is this helps me when I graph it to figure out a window if it's difficult to find a window. So what you do to find the bounds is you set the two curves in terms of x equal to each other, and then you solve this. When you solve this, because I have an x squared and x, we're going to move everything to one side and factor. And again, if it's a negative x squared, it's easiest if you move that to the other side. Then you don't have to factor with a negative first term. And this is x squared plus 2x minus 5 because I have no like terms. I'm going to move the 6x over to the other side by subtracting it. And I'm going to move the minus 5 to the other side by adding it. This gives me 0 equals x squared minus 4x. And the 5's add to 0, so they cancel. Then I'm going to factor this. It's two terms. There's a greatest common factor of x, which leaves me with x minus 4. And then I set each of these equal to 0. So these are my two x values. So that would be what I would put here, like this is 0 and 4. And then to figure out which curve is on top, we generally look at the graph. So we're going to go to our y equals and put these two curves in, one in y1, the other one in y2, which I already did. For the negative, make sure you're using this negative and not a minus. If you use the minus, it will give you an error. From there, I went to window and I made my window so that my x values were a little bit less than 0 and a little bit more than 4, because I knew that was the region I was focused on. So I did -2 to 6. And then I just left my y min and y max as the standard from -10 to 10. And I left the scale for both the x and the y to be 1. And if you graph it, then you get a pretty good window. And again, you don't have to find the x-intercepts. You can graph it and then just play with the window to get it so you can see. So from this, I can tell that this blue curve, which was my y1, which is the negative x squared plus 6x minus 5, is above this red curve from x equals 0 to x equals 4, since that's the region I'm interested in. So when I do this, f of x is going to be this curve, because that's on top. And g of x is going to be the 2x minus 5. Okay. And you should always put dx at the end because we need to know what we're integrating with respect to. So then I'll simplify a little bit. So I have 6x minus 2x, which is 4x, and minus 5 minus a -5. So those are going to cancel because this becomes like a +5 here. So I get this, and then I'm going to integrate it. So I'd recommend integrating this by hand and practicing it. Just to keep the video short, I'm going to do it on the calculator. But again, on the exam, you are going to be asked to do these by hand. So on the calculator, again, to check it, you hit math, go down to number 9 for FINT. We put our bounds. And then I'm going to put negative x squared plus 4x dx and hit enter. And I get 10.66. It's easier to put them in fractions. So if I do math and then frac, I get 32/3. And that would be the area between those two curves. And you can do this by hand and confirm you get the same thing. So that's how you find the area between two curves when they don't tell you the x values. So if you have any questions, let me know. I guess just one thing, just in case, if you have an old calculator, you would do like FN int. You'd hit the same command, but it will say this. And then you type the curve, comma, x, comma, and then lower bound, upper bound. So if you don't get this when you put it in your calculator, but instead get FN int and then parentheses with it blinking, this is what you'll type in. So again, if you have questions, please let me know.